This is a theory part I will write for this experiment. So you will notice that I use a letter A as the substance. Is because we are going to measure the parameters for two chemicals. So I just use the letter A to represent the generic information. If you are only to study one chemical, for example, ethanol in the system, there is no need to write generic scenario. I will just write ethanol parenthesis gas equal to ethanol parenthesis a liquid. Okay, I will be more specific if I'm only using one chemical. You can see if I want to use this equation, K equilibrium equal to AA divided by a gas phase, a liquid phase. Then we need to define what's AA. So usually we know from the textbook that that's activity, and the K would be the equilibrium constant. However, in this paper, we still need to define that. So I would put a sentence down where AA represents the activity of the substance in the liquid or gaseous phase state, respectively. And KEQ is the equilibrium constant. I will say something like that. And each equation, including the chemical reaction, should be numbered. So number 6 is the experimental session. This one is easy to write because you have done the experiment. There's a couple things you need to notice. Do not write a step-by-step how to do section. I included some writing samples on Canvas. You can see that it's just usually not step-by-step. So just briefly describe what should be done in this part. Always use the past tense, third person. Do not say, I did this, I did that, and try to say what was done. If you are using non-common chemicals, so for example, you are using some homemade chemicals, and you should give sources of where you get the materials from. Show a figure of apparatus is usually useful, and every picture or schematic of the apparatus is a figure, should be given a figure number, and also come with a caption describing what's in that figure. You should include the instrument setting, just the key settings, not all settings. One important setting of the instrument is the sensitivity level. So in the experiment 2, the measurement that we have are two parameters, pressure and temperature. You should state the pressure is measured to +1 -1 torr, and the temperature was measured to ±0.1 degrees C, something like that. Readers can figure out what instrument sensitivity by your results. Write everything in paragraphs, not in bullet. Here I show an example of how you're going to put the figures in this part. So you would have a statement, and during the statement, you want to guide your reader to the figure. So when reader reads through this text, you'll know at which point he or she should refer to a figure there. So I mentioned there's a figure 1 there, and when the reader goes to the figure 1, they can see, okay, it's a figure right there, and there is a figure number, and there should be a short description of what's in that figure. Okay, so I would say a schematic of the vapor pressure apparatus. That's an example of brief describing the experiment steps. Number 7, result, is one of the most important sections in your report. You should present your data and the results. So data means raw data, and the results means you'll analyze the data. And in this section, do not discuss the meaning of results just yet. Wait that part until the discussion session. Here, utilize tables, graphs, spectrum to present your result. And it's the same as figures. Tables get a table number and also a caption describing the count. For example, you can say table 1, tabulated pressure and the boiling point temperature data for cyclohexane. If you're going to show a number in the table, make sure includes unit. That's very important. A number does not come with the unit, doesn't mean anything in a scientific paper. And also the uncertainty of that number. Same for the graphs and the plot. So if you want to show a linear relationship between the pressure and the boiling point, you want to show a graph, and that graph needs to come with a number, also a figure number, and also a short caption. It's the same as figures and schematic. Guide your reader through the tables and the graphs. So in your text, always ask your reader to look at the table at a certain point. Here is one example of the linear plot. This is the natural log of Ray Hansen. Here is 1,000. Okay, so here is not 1, it's 1,000 over a temperature. The unit is per Kelvin, and the Ray Hansen unit is per mole per second. Okay, so in this graph, it's showing a linear relationship. Do not connect the dot. Okay, as you see from the graph, do not connect the dot. So reader will have a better understanding where your data point is sitting at. Okay, but you need to show the regression or whatever your fit is. So show your regression, that's a trend line, just show the trend line. And in your plot, again, make sure show units. So a number without unit doesn't mean anything. Show always show unit whenever you're talking about the number. This figure comes with a figure number. So figure number 2. This is a Arrhenius plot, and that's based on equation 4. And that's natural log of k versus 1 over t. It's actually, in this case, 1,000 over t of the data summarized in table 3. So from here, you can see if the readers want to see the exact value of the data point, they can refer to table 3. And the energy of activation is obtained from the slope. So that also gives some information how to get the energy of an activation just based on that plot. And in the text part, you can say something like that. So the table 2 summarizes the data, examine the temperature dependence of the Ray constant of the bromination reaction. So bromination reaction will be our experiment 5, parenthesis figure 5. So in here, readers know that if they want to see that dependence, they can go to figure 5 for that dependence. And a plot of equation 6. So here, using that phrase that describes the mathematical relationship that's shown in figure 2. If the reader are curious about what's the equation behind this plot, they can use equation 6. Okay. So that's why you want to number every equation. You don't need to repeat whatever equation there some cited here. You just need to tell readers that you have a certain number of equation there. Okay. The activation energy for the rate determining step was obtained from the slope of Arrhenius plot, where slope equal to minus EA divided by R, and was found to be whatever value with uncertainty and unit. So when you have a table, make sure each table get a table number and a caption. So make sure when you have a column, so if you are going to make a column, the head of the column need to be clear and easy to understand. You should include unit here. In here, the unit is per second for, this is a recastant. And that's a temperature, and the unit is Kelvin. And also, if possible, include the uncertainties for all the numeric values.